Hello, good morning students. Welcome back to online CET class. In the previous video, we already discussed some multiple choice questions on the topic IUPAC nomenclature of organic compounds. In this video, I'm going to explain or discuss some more examples on the isomerism concept. Let's move with the question. These questions based on your isomerism concept. During this time, first you know what are the types of isomerism, what are structural and what are position isomerism, chain isomerism, functional as well as metamerism, etc. Is it right? Yes. The question is, which of the following compounds are mesoforms? Yes. Students, remember these type of questions are usually observed in presence of NEET as well as JEE examination. So I select most important questions which are provided in your CET material. Okay, what is the question? Which of the following compounds are mesoforms? During this time, first you know what are mesocompounds. Students, remember mesocompounds, they contain plane of symmetry first. They contain plane of symmetry. Yes, I write some points related to the mesocompounds here. Mesocompounds means they contain plane of symmetry. ಅಲ್ಲಿ ಏನಿರ್ತದಂತ plane of symmetry ಕಂಡು ಬರ್ತಿರ್ತದೆ. Plane of symmetry ಇರ್ತದಂತ ಅಲ್ಲಿ. Okay. Next, they contain chiral carbon atoms. What is chiral carbon atom? You remember the point? Chiral carbon atom is also called as asymmetrical carbon atom. What is asymmetrical carbon atom? Asymmetrical carbon atom means one of the carbon atom, it is surrounded by 4 different groups. Is it right? Yes. A chiral carbon atom is one of the atom contain 4 different attachments. Is called chiral carbon atom. A carbon atom with 2 or more same attachments such as 2 or 3 hydrogen atoms is not a chiral carbon atom. Okay, students. Compounds having chiral center or chiral carbon atom and have plane of symmetry or center of symmetry are known as mesocompounds. This is the definition for mesocompounds. Is it right? Yes. Now come to the structures. Observe carefully. Which of the following compounds are mesoforms? One, and observe the first structure, second structure and third structures. Is first structure contain plane of symmetry? Is it right? No, because here symmetry means they contain similar groups. Here CH3 group is present, but here CH2 CH3 is present. Is it right? No, this is don't contain similar groups. But when you observe this compound, here also CH3 group, here also CH3, here H, and this also contain H. Okay, and Cl, Cl. It contains similar groups, but if you fold this according to this plane of symmetry, is it right? They do not close with one another. ಈಗ ಸಪೋಸ್ ಈ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅನ್ನು ಇಲ್ಲಿ ಮೇಲೆ ತಗೊಂಡು CH3 ಏನಾಗ್ತದೆ, ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಬರ್ತದೆ, ಬಟ್ ಇಲ್ಲಿ Cl ಏನಾಗ್ತದೆ, H ಮೇಲೆ ಬರ್ತದೆ, ಇಲ್ಲಿ H Cl ಮೇಲೆ ಬರ್ತದೆ. ಓಕೆ, ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಸಿಮೆಟ್ರಿ ತಪ್ಪೇದ ಅಂತ ಅರ್ಥ. therefore it is also not a mesoform. Yes. But come to the point of third structure. If you take a plane here, okay, at the time if you fold this one, this CH3 group correctly matched with this CH3 group. Is it right? Therefore it follows plane of symmetry, and according to the question this one is the mesoform. Means the third structure only follows the meso rules. Therefore option B is the right answer. Yes, remember students, mesocompounds contain plane of symmetry, chiral carbon atoms as well as center of symmetry. Students, next question number 33. What is the question? What is the relationship between the molecules in the following pairs? What is the relationship present between the molecules in the following pairs? Here two Fisher projections formula is given. Yes, the options are enantiomers, diastereomers, option C identical, option D structural isomers. Students, before going to the question answer, first you recall what are identical structures, what are enantiomers, what are diastereomers. I write some points related to this question here. Okay, in presence of points. First one, identical. Is it right? What are identical structures, students? Identical structures means they contain mirror images and they are superimposable. They're superimposed and they contain same configuration. Same configuration. If they follows these points, then the structures are identical. And what are enantiomers? What are enantiomers? They contain mirror images. They contain mirror images and non-superimposed. 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 And they contain different configuration. Different configuration. Next, another point about diastereomers. What are diastereomers? Remember students, diastereomers are non-mirror images. Non-mirror images. And one important thing in presence of diastereoisomers is one or more different configuration. One or more different configuration is observed, but not all. Yes, ಅಂದ್ರೆ ಇಲ್ಲಿ ಒಂದು ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಏನಾಗಿರ್ತದೆ, ಸಿಮಿಲರ್ ಕಾನ್ಫಿಗರೇಷನ್ ಒಳಗೊಂಡಿರ್ತದೆ, ಅಂದ್ರೆ ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಲ್ಲಿ in presence of diastereoisomers. Okay, you remember these points, then it is very easy to answer the question like this. Okay, now come to the question. What is the relationship between the molecules in the following pairs? Two structures are given. What is your answer? Students, in the given problem, the structure undergo 180-degree rotation. Is it right? Yes, ಈ ಎರಡು ಸ್ಟ್ರಕ್ಚರ್ ನೋಡಿದಾಗ ಏನಾಗಿದೆ, ಒಂದೇ ಸ್ಟ್ರಕ್ಚರು ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ CHO ಅದ. ಈಗ ಇಲ್ಲಿ ಈ ಸ್ಟ್ರಕ್ಚರ್ನಾಗ ಏನಾಗಿದೆ, ಇದು ಕೆಳಗೆ ಬಂದದ. ಇಲ್ಲಿ CHO ಅನ್ನೋದು ಏನು ಬಂದದ್ರಿ, ಕೆಳಗೆ ಬಂದದ. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ 180 ಡಿಗ್ರಿ ಏನಾಗಿದೆ, ರೊಟೇಷನ್ ಆಗಿದೆ. ಈ 180 ಡಿಗ್ರಿ ರೊಟೇಷನ್ ಆದಾಗ CHO ಇದ್ದದ್ದು ಮ್ಯಾಲ ಇದ್ದದ್ದು ಕೆಳಗೆ ಬಂದದ, CH2OH ಕೆಳಗೆ ಇದ್ದದ್ದು ಮ್ಯಾಲ ಬಂದದ. ಅದೇ ತರ ಈ ಕಡೆ ಏನು OH ಇದ್ದದ್ದು ಈ ಕಡೆ ಬಂತು, ಈ OH ಇದ್ದು ಈ ಕಡೆ ಬಂತು. ಹೌದಾ? ಅಂದ್ರೆ ಇಲ್ಲಿ ಪೊಸಿಷನ್ ಡಿಫ್ರೆಂಟ್ ಆಗಿದೆ. ಎಸ್, then ಏನಾಗಿದೆ, what is your answer? Is it mirror images? Yes, 180-degree rotation ಆಗಿದೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಐಡೆಂಟಿಕಲ್ ಸ್ಟ್ರಕ್ಚರ್ ನೋಡಿದ್ರಿ, ಅಲ್ಲಿ ಏನಾಯ್ತು, ಸಪೋಸ್ ನೀವು 180-degree rotation ಮಾಡಿದ್ರೆ ಏನಾಗ್ತದೆ ಅದನ್ನ ಸ್ಟ್ರಕ್ಚರ್ ಪುನಃ ಬರ್ದ್ಬಿಡ್ತೇನೆ ನಾನು ಇಲ್ಲಿ. ಹೌದಾ? ಓಕೆ, ಇಲ್ಲಿ ನೋಡ್ರಿ, ಫಸ್ಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನ ನಾನು ಇಲ್ಲಿ ಬರೀತೇನೆ. ಇಲ್ಲಿ ಏನಾಗಿದೆ, CHO ಇದ್ದದ್ದು ಇಲ್ಲಿ CH2OH ಆಯ್ತು. ಇಲ್ಲಿ ಎಷ್ಟು ಅದಾವ, 1 2 3 4. ಇಯರ್ CH2 ಇದ್ದದ್ದು ಇಲ್ಲಿ CHO ಬರೀತೇನೆ. ನೆಕ್ಸ್ಟ್ ಇಯರ್ OH and here H, and here OH, here I write H, here H, here OH, here OH, here H. ಈಗ ಈ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನ ಅಂದ್ರೆ ಈ A ಸ್ಟ್ರಕ್ಚರ್, ಇದು A ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ಕೊಂತಾನೆ, ಇದು B ಅನ್ಕೊಳ್ತಾನೆ. ಈಗ ನಾನು ತಗೊಂಡಿದ್ದು C ಸ್ಟ್ರಕ್ಚರ್. ಹೌದಾ? ನಾ ಏನ್ ಮಾಡೇನಿ, ಜಸ್ಟ್ ಈ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನ ಈಗ ಇಲ್ಲಿ ರೊಟೇಷನ್ ಮಾಡೇನಿ. ಹೌದಾ? ಓಕೆ, ಹಾಗಾದ್ರೆ ಈಗ ಈ ಎರಡೂ ಸ್ಟ್ರಕ್ಚರ್ ನೋಡಿದ್ರೆ ನಮ್ಗೇನ್ ಅನಿಸ್ತದ? ಇಲ್ಲಿ ಐಡೆಂಟಿಕಲ್ ನೋಡ್ರಿ, ದೇ ಆರ್ ಮಿರರ್ ಇಮೇಜಸ್. ಮಿರರ್ ಇಮೇಜಸ್ ಅದಾವ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಮಿರರ್ ಇಮೇಜಸ್. ಈಗ ನೋಡ್ರಿ, OH ಈ ಕಡೆ ಬಂದದ. ಇಲ್ಲಿ ಸಪೋಸ್ ನಾ ಈ ಸ್ಟ್ರಕ್ಚರ್ ಮತ್ತು ಈ ಸ್ಟ್ರಕ್ಚರ್ ಅಂದ್ರೆ ಲಾಸ್ಟ್ A ಮತ್ತು C ಸ್ಟ್ರಕ್ಚರ್ ಮಧ್ಯೆ ಮಿರರ್ ಇಟ್ರೆ ಇಲ್ಲೆಲ್ಲ ಏನಾಗಿದೆ, ಇದೀಗ ಮಿರರ್ ಇಮೇಜಸ್ ಕಂಡು ಬರಾಕತ್ತದ, ಸೂಪರ್ ಇಂಪೋಸ್ಡ್ ಅಂತೆ. ಹೌದಾ? ಈಗ ಇದು ನೋಡ್ರಿ, ಈ ಇದನ್ನು ತೊಗೊಂಡು ಹೋಗಿ ನಾನು ಏನು ಮಾಡ್ಬೋದು ಇಲ್ಲಿ ಸರಿಯಾಗಿ ಇದರ ಮೇಲೆ ಇಡ್ಬೋದು. ಹೌದಾ? ಮಿರರ್ ಇಮೇಜಸ್. ಸರ್ ಮತ್ತೆ ಇದನ್ನ ಯಾಕೆ ಬರ್ಕೊಂಡ್ರಿ? ಈ ಸ್ಟ್ರಕ್ಚರ್ಗೆ ನೀವು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಈಸಿ ಆಗ್ತದೆ. ಸೂಪರ್ ಇಂಪೋಸ್ಡ್ ಆ್ಯಂಡ್ ಸೇಮ್ ಕಾನ್ಫಿಗರೇಷನ್. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲಿ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಮ್ಯಾಲ್ CH2OH ಅದ, ಇಲ್ಲಿ H ಅದ, ಇಲ್ಲಿ OH, ಸೇಮ್ ಕಾನ್ಫಿಗರೇಷನ್ ಕಂಡು ಬರಾಕತ್ತೈತಿ. ಎಸ್, therefore the given structures are identical structures. Yes. Next, question number 35, students. Rank the following substituent groups in order of decreasing priority according to the Kohn-Ingold-Prelog system. Yes, Kohn-Ingold-Prelog system. It is simply written as CIP system. Remember one thing, students. The point of difference is applicable in CIP rule Kohn-Ingold-Prelog system on the basis of atomic number or atomic mass. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತದೆ, CIP ಸಿಸ್ಟಮ್ದೊಳಗೆ ಅಟಾಮಿಕ್ ನಂಬರ್ ಅಥವಾ ಅಟಾಮಿಕ್ ಮಾಸ್ ಆಧಾರದ ಮೇಲೆ ಏನು ಮಾಡ್ತಾರೆ, ಒಂದು ಪ್ರಿಯಾರಿಟಿ ಬರ್ತಾ ಹೋಗ್ತಾರೆ. ಸ್ಟೂಡೆಂಟ್ಸ್, ಇನ್ ಸ್ಟ್ರಕ್ಚರ್ 1, see here, in structure 1 it contains CH, here one CS3, I write here another one CS3. Here 2 carbon atoms are attached. Is it right? 2 carbon atoms. ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಈ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ 2 ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಅಟ್ಯಾಚ್ ಆಗ್ಯಾವ. In second structure, this one is first structure, and in second structure CH here, and one high mass atomic mass containing group bromine Br is attached here. Next, third one here, similarly like this, CH2 Br. Yes, it contains only one carbon atom and high mass group is attached here. Therefore, its mass becomes high. But here is a straight chain. Here one group is attached to the single carbon atom. Is it right? Yes. Therefore, in presence of Kohn-Ingold-Prelog system, according to this rule, on the basis of atomic number and atomic mass, the priority is written. Therefore, the correct answer for this question is second one is greater than first one and greater than third one. Means here mass of this compound becomes very less because the number of hydrogens are less here. Is it right? Number of hydrogen atoms are less here. Therefore, 2 is greater than 1, greater than 3. Where is the answer? 2 is greater than 1, greater than 3. Option D is the right answer. Next, question number 36, students. Optically inactive compound from the following is. Options are given. Option A, 2-chloropropanyl. Option B, 2-chlorobutane. Option C, 2-chloropentane. Option D, 2-chloro-2-methylbutane. Students, just to recall the points or conditions to be observed, the compound shows optical activity. Optical active ಇರ್ತಕ್ಕಂಥ ಕಂಪೌಂಡ್ಸ್ ಏನನ್ನು ಒಳಗೊಂಡಿದ್ರೆ ಮಾತ್ರ ತೋರಿಸ್ತದೆ ಅನ್ನೋದು ಕಾನ್ಸೆಪ್ಟ್ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. ಸ್ಟೂಡೆಂಟ್ಸ್, you know what are the conditions of the compounds to be optically active? One is it must contain a symmetrical carbon atom. Which type of compound shows optical activity? They contain a symmetric carbon atom. What is a symmetric carbon atom? One of the carbon atom, if it is surrounded by 4 different attachments, or this is asymmetric carbon atom is also called as chiral carbon atom. Remember. Next, another one point, they are non-superimposed. They are non-superimposed mirror images. ನೋಡ್ರಿ, ಎಂಥ ಕಂಪೌಂಡ್ಸ್ ಆಪ್ಟಿಕಲ್ ಆಕ್ಟಿವಿಟಿ ತೋರಿಸ್ತಾವ ಅಂದ್ರೆ ಆ ಕಂಪೌಂಡ್ನಾಗ ಮಸ್ಟ್ ಆ್ಯಂಡ್ ಶುಡ್ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇರಲೇಬೇಕು, ಮತ್ತು ಅವು ಮಿರರ್ ಇಮೇಜ್ ಆಗಿರಬೇಕು, ನಾನ್ ಸೂಪರ್ ಇಂಪೋಸ್ಡ್ ಆಗಬೇಕು. ಅಂಥವು ಏನಾಗ್ತಾವಂತ ಆಪ್ಟಿಕಲ್ ಆಕ್ಟಿವಿಟಿ ತೋರಿಸ್ತಾವಂತ. ಹೌದಾ? ಓಕೆ, ಹಾಗಾದರೆ ರೈಟ್ ದ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಆಫ್ ಆಲ್ ದ ಗಿವನ್ ಆಪ್ಷನ್ಸ್ ಕೇರ್ಫುಲಿ ಆ್ಯಂಡ್ ಅಬ್ಸರ್ವ್ ವಿಚ್ ಒನ್ ಕಂಟೇನ್ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್. Okay, students, I directly go to the answer for this question, that is option D. You yourself, you write the structure of 2-chloropropanyl, 2-chlorobutane and 2-chloropentane, as well as 2-chloro-2-methylbutane. when you write the structure of last one means 2-chloro 2-methyl butane, I write the structure here 1 2 3 4 carbon atoms, and second one contain chloro group, and third one contain, sorry, second one contain methyl group means CS3, and you know here CS3, here CH2, and here CS3. This one is ethyl group. And okay, question is optically inactive compound, is it right? Yes, this one is CS3 and this one is CS3. Students, you know the concept which type of compound shows optical activity? They contain asymmetric carbon atom. Now you write the structure, it contain asymmetric carbon atom or not? You observe. Yes, ಇಲ್ಲಿ ನೋಡ್ರಿ ಈ ಕಾರ್ಬನ್ ಆಟಮು ಇಲ್ಲೊಂದು CS3 ಅದ, ಇಲ್ಲೊಂದು CS3 ಅಂದ್ರೆ ಸಿಮಿಲರ್ ಗ್ರೂಪ್ಸ್ ಆದವಲ್ರಿ, ಮತ್ತೆ ಇದು ಹೇಗೆ ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಆಗ್ತದೆ? ನೋ, ಇಟ್ ಈಸ್ ಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್. ಎಸ್, ದಿಸ್ ಈಸ್ ಒನ್ ಆಫ್ ದ ಆಪ್ಟಿಕಲಿ ಇನ್ಆಕ್ಟಿವ್ ಕಂಪೌಂಡ್. ಆಪ್ಟಿಕಲಿ ಇನ್ಆಕ್ಟಿವ್. ಎಸ್, ಆಪ್ಟಿಕಲಿ ಆಕ್ಟಿವ್ ಇಲ್ಲ ಇದು. ಹಂಗಾದ್ರೆ ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಟ್ರೈ ದ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ 2-chloropropanol. Propanol, okay. Prop means 3 carbon atoms and propanol means aldehyde group is present. Here 1H and here 1H, here CS3. Is it right? This structure is also 2-chloro, okay. Sorry, 1 2, okay. Here Cl group 2-chlorobutane. Sorry, 2-chloropropanol. Is it right? Here 1 2 and this one is 3. Okay, whether observe this one is a symmetric carbon atom or not, because here CHO group, aldehyde group, Cl group, here H and here CS3. Is it right? This is a symmetric carbon atom. What is a symmetric or chiral carbon atom? It contains 4 different groups around H. Okay, therefore this one is optically active, this one is also optically active, this one is also optically active. When you write the separate structure, then only you would know the answer. Okay, the answer for this question means optically inactive is 2-chloro 2-methyl butane. Okay, next question number 37, students. The number of structural isomers for C6H14 is. Okay, students, structural isomers. When you observe the molecular formula of the given compound, C6H14 means it is one of the alkane. Is it right? Yes, because it follows the general formula CnH2n plus 2. Okay, again ಕೇಳಾರವರು ಈ ಒಂದು C6H14 ಎಷ್ಟು ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್ ಬರೀಬಹುದಪ್ಪ ಅಂತ ಕೇಳ್ಯಾರ. ಓಕೆ, ನೀವು ಅವಾಗ ಏನು ಮಾಡ್ತೀರಿ? ಬರೆಯಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಿ. ಅವಾಗ ಹಿಂಗೆ ಬರೀತೀರಿ ಏನಂತ? ಸರ್ ಇದೊಂದು ಸ್ಟ್ರಕ್ಚರ್ ಯಾವುದು C6 ಅದ ಅಂತಂದ್ರೆ 6 ಕಾರ್ಬನ್ ಆಟಮ್, 1 2 3 4 5 6 ಇದೊಂದು ಬರೀಬಹುದು. ನೆಕ್ಸ್ಟ್ 1 2 3 4 5. okay, itself is not, and I write here 1. okay, 1 2 3 4 5, 1 2 3 4 5, and this one is 6. okay, this one is also another structure of C6H14. ಸರ್ ನೀವು ಅನ್ಬೋದು ಈಗ ಸರ್ ಹಿಂಗೂ ಬರಿಬೋದಲ್ರಿ ಹೊಳ್ಳಿ ಹಿಂಗೆ 1 2 3 4 5 and this one. okay, these two structures are identical. okay, ಈ ಥರ ಇದ್ದಾಗ ನೀವು ಎರಡನ್ನ ಕೌಂಟ್ ಮಾಡ್ಕೊಳಂಗಿಲ್ಲ. ಇದು ಎರಡು ಸ್ಟ್ರಕ್ಚರ್ ಒಂದೇ. ಇದು ಏನು, ಈ ಸ್ಟ್ರಕ್ಚರನ್ನು ಹಿಂಗೆ ಇಡೋ ಬದಲಿ ಉಲ್ಟಾ ಇಟ್ಟಂಗೆ ಇದು, ಹೌದಾ? ಓಕೆ, ನೆಕ್ಸ್ಟ್ another type of structure containing molecular formula C6H14 is, it is like this. yes, this one is also another isomer and another structure, and this one 1 2 3 4 5 6. okay, right. Next another structure, this one. is it right? 1 2 3 4 5 6. okay, these three, sorry, these are the how many structures? This one is 1, this one is 2, this one is 3, this one, sorry, this is not, because it is the identical molecule. okay, 3 4 5 isomers of the compound containing molecular formula C6H14. ಸರ್ ಇದಕ್ಕೆ ಟೈಮ್ ಭಾಳ ತಗೋತದೆ, ಹೌದಾ? ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ದೆರ್ ಈಸ್ ಎ ಒನ್ ಟ್ರಿಕ್ ಫಾರ್ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ದ ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್ ಆಫ್ ಅಲ್ಕೇನ್ಸ್ ಓನ್ಲಿ. ಓಕೆ, ಅಲ್ಕೇನ್ಸ್ದಾಗ ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಕೆ ಒಂದು ಫಾರ್ಮುಲಾ ನಿಮಗೆ ಕೊಡ್ತೇನೆ ನಾನು. ರಿಮೆಂಬರ್ ದಟ್ ಫಾರ್ಮುಲಾ ಸ್ಟೂಡೆಂಟ್ಸ್. ಇಟ್ ಈಸ್ ವೆರಿ ಈಸಿ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ನಂಬರ್ ಆಫ್ ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್ ಆಫ್ ಅಲ್ಕೇನ್ಸ್. ಏನು ಅಲ್ಕೇನ್ಸ್ ಇದ್ದಾಗ ಅದು ಓನ್ಲಿ ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್. Students remember acyclic, cyclic ಈ ತರ ಏನಾರ ಸಪ್ರೇಟ್ ಆಗಿ ಕೇಳಿದಾಗ ಇದನ್ನ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ. ಓನ್ಲಿ ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್ ಕೇಳಿದಾಗ ಮಾತ್ರ ನೀವು ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು. ಏನದು ಫಾರ್ಮುಲಾ? ರಿಮೆಂಬರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, the formula means this one is the trick to find the number of structural isomers for alkanes. Is that okay? Right here, total number of structural isomers of alkanes is calculated by formula equal to 2 to the power of n minus 4 plus 1. Yes, use this formula, then it is very easy to calculate the number of structural isomers. Okay, in the problem they given C6 means here n, it indicates the number of carbon atoms, that is 6 here. Therefore I write 2 to the power of 6 minus 4 plus of 1. 6 minus 4 means 2. 2 to the power of 2 plus 1 equal to 2 to the power of 2 means 4. 4 plus 1 equal to 5. 5 is your answer. There are 5 structural isomers already written. Okay, it is very easy to calculate. Remember this formula. Therefore the answer for this question is option D. Remember students, it is only for structural isomers of alkanes. Okay, ಈಗ ನೀವು ಅನ್ಬೋದು ಸರ್ ಹಂಗಾರೆ ಅಲ್ಕಿನ್ಸ್ಕ ಮತ್ತು ಅಲ್ಕೈನ್ಸ್ಕ ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಬೇಕು ನಾವು. Okay, if you want to know that, yes, I write here because here space is present. Okay, for students, if you want to write the number of structural isomers for alkenes and alkynes, then there is a different formulas. If they asked in the examination, you follow these formulas. ಇದನ್ನ ಒಂದು ಕಡೆ ಸಪ್ರೇಟ್ ಆಗಿ ಬರ್ಕೊಡ್ರಿ. ನಿಮಗೆ ಈಗ ಆಲ್ರೆಡಿ ಅಲ್ಕೇನ್ಸ್ ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್ ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ಒಂದು ಫಾರ್ಮುಲಾ ಕೊಟ್ಟೆ ನಾನು. ಏನದು? 2 to the power of n minus 4 plus 1. ಅದೇ ತರ ಅಲ್ಕೇನ್ಸ್ ಮತ್ತು ಅಲ್ಕೈನ್ಸ್ ಇದ್ದಾಗ ಹೆಂಗೆ ಕಂಡುಹಿಡಿಬೇಕು ಅನ್ನೋದನ್ನ ಈ ಫಾರ್ಮುಲಾ ತಿಳಿಸ್ಕೊಡ್ತದೆ. ಯಾವುವು? ಇಲ್ಲಿ ಸ್ಪೇಸ್ ಇಲ್ಲ, ಇಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಪ್ಲೇಸ್ ತಗೊಳ್ತೇನೆ ನಾನು. Okay, see here students, for the calculation of isomers of alkenes, structural isomers in alkenes daga. Okay, see here, I write the formula here. Alkenes, there are two formulas. If the alkene containing odd number of carbon atoms, one alkene dolaga odd number of carbon atoms ittu andre, at that time use the formula 2 to the power of n minus 2. What is the n? It indicates, and it indicates the number of carbon atoms. Is right? ಯಾವಾಗಿದು ಅಲ್ಕೀನ್ಸ್ ದೊಳಗೆ ಆಡ್ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಅಟಮ್ಸ್ ಇದ್ದಾಗ 2 to the power of n minus 2 ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದ್ರಿ ಅಂದ್ರೆ ನಿಮಗೆ ಟೋಟಲ್ ಐಸೋಮರ್ಸ್ ಸಿಗ್ತದೆ, ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್. ಅದೇ ಇವನ್ ನಂಬರ್ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ, ಇಫ್ ದ ಕಂಪೌಂಡ್ ಕಂಟೇನ್ ಇವನ್ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್, ದೆನ್ ಯೂಸ್ ದ ಫಾರ್ಮುಲಾ 2 to the power of n minus 2 plus 1. ಅಲ್ಕೀನ್ಸ್ ದೊಳಗೆ ಇವನ್ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇದ್ರೆ ಯೂಸ್ ದ ಫಾರ್ಮುಲಾ 2n minus 2 plus 1. And one more formula here, total number of ring structures. Total number of ring structures or ring isomers calculated by formula n minus 1. Is it right? Yes. Next, for alkynes. For alkynes. Alkynes hege odd number of carbon atoms. If alkyne contain odd number of carbon atoms, then use the formula to calculate the number of structural isomers, that is 2 to the power of n minus of 2n. Here this n is not on the power, this is multiplied with 2. Yes. Next, even number of carbon atoms. Alkyne containing even number of carbon atoms, then use the formula 2 to the power of n minus of bracket 2n minus 1. Yes. And total number of open chain here. Total number of open chain. Total number of open chain isomers can be calculated by using formula n into n minus 2. Okay students, please write these formulas separately, and remember, it helps to the calculation of structural isomers in alkanes, alkenes as well as alkynes. Okay, next question number 38. Right? Yes, question number 38. Malic acid and fumaric acids are, okay, malic acid and fumaric acids are either chain isomers or functional isomers or tautomers or geometrical isomers. Students, for answering this question, first we write the structure of malic acid and fumaric acid separately. Okay, I write here malic acid, malic acid. Okay, this one is H, here C, double bond C, here H, and here COOH, here also COOH. And fumaric acid, another one, fumaric acid, as the structure is similar to this one, but the position of group is different here. This COH, here double bond C, here COOH, and here H. Is it right? ಏನು ಡಿಫ್ರೆನ್ಸ್ ಅದ ನೋಡ್ರಿ ಈ ಸ್ಟ್ರಕ್ಚರಲ್ಲಿ. ಈ ಕಡೆ COH, ಈ ಕಡೆ COH ಇತ್ತು, ಇಲ್ಲಿ H ಈ ಕಡೆ ಇತ್ತು. ಇಲ್ಲಿ ನೋಡ್ರಿ ಈ ಕಡೆ ಈ ಪೊಸಿಷನ್ ಅಷ್ಟೇ ಚೇಂಜ್ ಆಗಿದೆ. COH ಈ ಕಡೆ ಬಂದದ, H ಈ ಕಡೆ ಬಂದದ. ಹೌದಾ? ಎಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್, these are geometrical isomers. Why? Because there is a special arrangement of atoms around the double bond is observed. Remember students, malic acid is one of the cis isomer of butane dioic acid, whereas fumaric acid is the trans isomer. Yes, ಇವೆರಡು ಏನಿವು ಜೊಮೆಟ್ರಿಕಲ್ ಐಸೋಮರ್ಸ್ಗೆ ಎಕ್ಸಾಂಪಲ್ ಆದಂಥವುಗಳು. ಅದಕ್ಕಾಗಿ ಇದಕ್ಕೆ ನಮ್ಗೆ ಆನ್ಸರ್ ಯಾವುದು ಬರೀಬೇಕು? ನಾನೀಗಿಲ್ಲಿ ಆಪ್ಷನ್ ಡಿ, geometrical isomerism is the right answer. Next, question number 39, students. During debromination of meso-dibromobutane, the major compound formed is. During debromination means removal of bromine of meso-dibromobutane. Yes, the major compound is. First I write the meso-dibromobutane structure. I write here, okay. Observe carefully the reaction. Here I write CS3 and this one is CH, Br. Here carbon atom with H, Br, and this one is CS3. Sorry, I write here this one is CS3. Okay, I write here. Students, when this undergoes debromination means removal of bromine. Is it right? Yes, removal of Br2. At the time it becomes, or it gives the compounds like this, CS3, and here H, and here CH3. Is it right? Yes. Yes, what is this? This one is the transform, because here two similar groups present on opposite in direction. This one is trans 2-butene. Yes. And another product, the cis form of 2-butene is observed. But between the trans 2-butene and cis 2-butene, this one is the major product. Trans 2-butene is the major product. This one is the major product. Remember students, this one is major product. Therefore, option D is the right answer. Next, question number 40, students. The molecular formula of a saturated compound is C2H4Br2. Molecular formula of the compound ಏನಾಯ್ತಂತ? C2H4Br2 ಐತಂತ. The formula permits the existence of, yes, functional isomers, optical isomers, positional isomers, cis trans isomers. Okay, C2H4Br2 ಸ್ಟ್ರಕ್ಚರ್ ಹೆಂಗೆ ಬರಿಬೋದು ನಾನು? ಇಲ್ಲಿ ಎರಡು ಥರ ಸ್ಟ್ರಕ್ಚರ್ ಬರಿಬೋದು ನಾನು. ಹೇಗೆ ನೋಡ್ರಿ, ಇಲ್ಲೇ Br, ಇವೊಂದು CH2, ಇಲ್ಲೊಂದು CH2, ಇನ್ನೊಂದು Br, ಅಂದರೆ C2H4Br2 ಆಯಿತು. ಇದನ್ನ ಈ ಸರ್ ಹಿಂಗೂ ಬರಿಬೋದಲ್ರಿ ಅಂತ ನೀವು ಅನ್ಬೋದು. ಹೇಗೆ? CH ಬರಿತೇನೆ, ಮ್ಯಾಲಿಲ್ಲೇ Br ಬರಿತೇನೆ, ಇಲ್ಲಿ Br ಬರಿತೇನೆ. ಓಕೆ, ಉಳಿದಿದ್ದು CS3. ಎರಡು ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ C2H4Br2 ಅದೇ. ಓಕೆ, ಹಿಯರ್ ದ ಕಂಪೌಂಡ್ contains same molecular formula, but position of Br is changed here. Is it right? ಇಲ್ಲಿ ಪೊಸಿಷನ್ ಒಂದನೇದಕ್ಕೆ ಎರಡನೇದಕ್ಕೆ ಕಾರ್ಬನ್ ಐಟಮ್ ಮೇಲೆ ಇತ್ತು, ಒಂದನೇದ್ರೊಳಗೆ. ಹೌದಾ? ಈ ಒಂದನೇ ಸ್ಟ್ರಕ್ಚರ್ನಾಗ ಏನಿತ್ತು? ಒಂದನೇ ಕಾರ್ಬನ್ ಐಟಮ್ಗೊಂದು, ಎರಡನೇ ಕಾರ್ಬನ್ ಐಟಮ್ಗೆ Br ಗ್ರೂಪ್ ಅಟ್ಯಾಚ್ ಆಗಿದ್ದು. ಬಟ್ ಹಿಯರ್ ಓನ್ಲಿ ಒನ್ ಕಾರ್ಬನ್ ಐಟಮ್ ಕಂಟೇನ್ 2 Br ಗ್ರೂಪ್ಸ್, ಬಟ್ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ is same, C2H4Br2. Then your answer, only position of the Br group is changed. Therefore, this shows positional isomers. Therefore option C is the right answer. ನೀವು ಅನ್ಬೋದು ಸರ್ ಚೇನ್ ಐಸೋಮೆರಿಸಮ್ನ ತೋರಿಸ್ಬೋದಲ್ರಿ, ಯಾಕಂದ್ರೆ ನಮಗೆ ಹೇಳ್ಯಾರ ಸರ್ ಹಿಂದೆ ಲಾಸ್ಟ್ ಇಯರ್ದಾಗ ಏನಂತ, ದ ಕಂಪೌಂಡ್ಸ್ ಹ್ಯಾವಿಂಗ್ ಸೇಮ್ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಬಟ್ ಚೇಂಜ್ ಇನ್ ದ ಚೇನ್ ಆಫ್ ದ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಚೇನ್ ಐಸೋಮರ್ಸ್. ಹೌದಾ? ಹಾಗಾದರೆ ಇಲ್ಲಿ ನೋಡ್ರಿ ಆಪ್ಷನ್ದಾಗ ಅದನ್ನು ಕೊಟ್ಟಿಲ್ಲಲ್ಲ, ಅದಕ್ಕಾಗಿ ಆನ್ಸರ್ ಇಲ್ಲಿಲ್ಲ. ಓಕೆ, ಏನು ಕೊಟ್ರ ಆನ್ಸರ್ ನಮಗೆ ಪೊಸಿಷನ್, ಯಾಕಂದ್ರೆ ಪೊಸಿಷನ್ ಐಸೋಮರಿಸಮ್ದಾಗ ಹೇಳಿದ್ರು ಏನಂತ, compounds having same molecular formula but change in the position of the functional group or particular group. Okay, therefore option C is the right answer. Option C. Students, option C, position isomerism or position isomers. Next question number 43, students. Only two isomeric monochloro derivatives are possible for. Only two isomeric monochloro derivatives are possible for. Option A, N-butane. Option B, 2,4-dimethylpentane. Option C, benzene. Option D, 2-methylbutane. Yes, what is the answer? ಏನದ ಕ್ವಶನ್, ಓನ್ಲಿ ಟೂ ಐಸೋಮೆರಿಕ್ ಮೊನೋಕ್ಲೋರೋ ಡೆರಿವೇಟಿವ್ಸ್ ಅನ್ನ ಯಾವುದಕ್ಕೆ ಬರೀಬಹುದು ಅಂತ ಕೇಳ್ಯಾರ ಅವರು. Students, when you observe the given options, N-butane can have two isomeric monochloro derivatives as position 1 and 2. And if you go to the another examples, benzene have one only, 2,4-dimethylpentane will have 3. Is it right? Yes. But when you come to the point of N-butane, we write the isomers like this, monochloro derivative. Yes, I write one structure CS3, CH2 and CH, here CS3, is it right? And here one Cl is attached. Mono substituted, only two isomeric monochloro. Okay, one chloro matra illi baribodu. Next another structure CS3, CH2, 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 Cl. This is another. Therefore N-butane can only have two isomeric monochloric derivatives. Yes, therefore option A is the right answer for this question. Next question number 50. Tautomerism will exhibited by. Okay students, just recall the previous year concept, tautomerism. During tautomerism, I think you already learned, tautomerism is also called as keto-enol formation or keto-enol conversion. Which type of compound shows the tautomerism? Remember students, the compounds which contain alpha hydrogen atom, they shows tautomerism or they exhibit tautomerism. The point is, tautomerism exhibited by oscillation of hydrogen atom between two polyvalent atoms present in the molecule. Students, when you observe the given options, in that the given structure D only has alpha hydrogen atom. Yes, among the given options only D option has alpha hydrogen atom. Therefore it shows tautomerism, whereas other do not shows, other structures do not show tautomerism. Because see here, when you come to the point of option D, I write the structure like this, RCH2 and one N, double bond O and another one O. Yes, is it right? Students, remember tautomerism, and I write the product another side here, and I write OH here. Here double bond O, it changes to OH, means ketone. Usually ketone form changes to enol form. Therefore this is also called as keto-enol formation. This one is nitro form. This one is acnitro form. Right? Yes, students. Now another point is, what are alpha hydrogen atom? ತಿಳಿದಿದೆ ಇದ್ರ ಬಗ್ಗೆ ನೆನಪಿಡಿ. ಒಂದು ಗ್ರೂಪ್ ಅಲ್ಲಿ ಒಂದು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಇರ್ತದಲ್ಲ, ಆ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಪಕ್ಕದಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಕಾರ್ಬನ್ ಆಟಮ್ ಯಾವಾಗಿದ್ರು ಅಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಆಗಿರ್ತದೆ. ಆ ಅಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೆ ಇರ್ತಕ್ಕಂಥ ಹೈಡ್ರೋಜನ್ಸ್ ಅಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್. ಓಕೆ, ಈಗ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲೊಂದು ಗ್ರೂಪ್ ಅದ ಇಲ್ಲಿ NO2 ಅಂತಕ್ಕಂಥದ್ದು. ಅದ್ರ ಬಾಜು ಇರ್ತಕ್ಕಂಥ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಆಯಿತು. ಆ ಅಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಜೊತೆ ಏನು ಹೈಡ್ರೋಜನ್ಸ್ ಅದಾವ ನೋಡ್ರಿ ಇಲ್ಲಿ, ಇವು ಏನಾಗಿರ್ತಾವೆ, ಇವು ಅಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ ಆಗಿರ್ತಾವೆ. ಇವು ಅಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್. ಓಕೆ, ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಆರ್ ಅದ. ಆರ್ ಅಂದರೆ CH2 ಇರ್ಬೋದು, CH3, CH2 ಹಿಂಗೆ ಮುಂದೆ ಹೋಗಿರ್ಬೋದು. ಇದು ಸರ್ ಗ್ರೂಪ್ ಅಂದರೆ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಬಾಜು ಇರ್ತಕ್ಕಂಥ ಕಾರ್ಬನ್ ಅಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್, ಅದ್ರ ಮೇಲೆ ಇರ್ತಕ್ಕಂಥ ಹೈಡ್ರೋಜನ್ಸ್ ಅಲ್ಫಾ ಹೈಡ್ರೋಜನ್. ಮುಂದೆ ಅಲ್ಫಾ ಆದ್ಮೇಲೆ ಬೀಟಾ ಬರ್ತದೆ, ಆಮೇಲೆ ಗಾಮಾ ಬರ್ತದೆ, ಮುಂದೆ ಹೋಗ್ತದೆ. ನಮಗೆ ಬೇಕಾಗಿದ್ದೇನೀಗ ಅಲ್ಫಾ, ಹೌದಾ? ಓಕೆ, therefore the correct answer for this question is option D. Students, remember alpha hydrogen atom containing compound shows tautomerism. Next question number 51, students. A compound of molecular formula of C7H16 shows optical isomerism. Compound will be a compound of molecular formula of C7H16 shows optical isomerism. Compound will be 2,3-dimethylpentane, 2,2-dimethylpentane, 2,4-dimethylpentane, none of these. Okay, students, organic compounds exhibit the property of optical isomerism only when their molecule contains a chiral carbon atom or a symmetrical carbon atom. Most of the chiral compounds have chiral centers, which is an atom bounded to 4 different atoms or groups. Is it right? Yes. When you observe the given options, first come to the point of option A, 2,3-dimethylpentane. Is it right? I write the structure 2,3-dimethylpentane here. This one is CS3, and here I write CH, here CS3, and here C, one of the H, and here CS3, here CH2, and here CS3. Yes, this one is the 2,3-dimethylpentane. What is the question? The compound of molecular formula C7H16 shows optical isomerism. Compound will be optical isomerism ತೋರಿಸಬೇಕಂದ್ರೆ ಏನು ಇರಬೇಕಂತ ಹೇಳೇನೆ ನಾನು, ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಆರ್ ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇರಬೇಕು ಅಂತ ಹೇಳೇನೆ. ಓಕೆ, ಅಬ್ಸರ್ವ್ ಹಿಯರ್ ದಿಸ್ ಕಾರ್ಬನ್ ಆಟಮ್, ಮಿಡಲ್ ಕಾರ್ಬನ್ ಆಟಮ್, it contains 4 different groups around it. Is it right? Yes, ಒಂದು H ಅದ, ಒಂದು CS3 ಅದ, ಒಂದು CH2 CS3 ಅದ, ಈಚೆ ಕಡೆ ಅಂದ್ರೆ CH3 CH3 CH ಅದ. ಓಕೆ, ಹಾಗಾದ್ರೆ this one is chiral carbon atom. Is it right? Yes. Therefore, option A is right answer according to the question. But you observe the option B, C, and D. Write the structures carefully, whether they contain a symmetric carbon atom or not. Is it right? Yes. But answer is option A only. Because it do not, students, when you observe the structure 2,3-dimethylpentane, it has one chiral carbon atom and do not have any symmetric element here. Is it right? Yes. Next question number 52. Okay, what is the question? Here 2 structures are given. Option A, they shows resonating structures. Option B, tautomers. Option C, geometrical isomers. Option D, optical isomers. ಏನಿದೆ ಇಲ್ಲಿ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಒಳಗೆ, ಎರಡು ಸ್ಟ್ರಕ್ಚರ್ ನೋಡ್ರಿ ಏನು ಡಿಫ್ರೆಂಟ್ ಆಗಿ ಕಾಣಕತ್ತದ. ಇಲ್ಲಿ ನೋಡ್ರಿ ಏನು ಮಾಡಿದ್ದಾರೆ, ಇಲ್ಲೇನು ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬರ್ದಿದ್ದಾರೆ. ಇದನ್ನ ಈಗ ಇಲ್ಲಿ ಏನು ಮಾಡ್ತಾನೆ, ನಾನು ಮೂವ್ ಮಾಡ್ತೇನೆ. ಆವಾಗ ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್. ಯಾಕಂದ್ರೆ ಮೊದಲು ಸಿಂಗಲ್ ಬಾಂಡ್ ಇತ್ತು, ಈಗ ನಾ ಇದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಮೂವ್ಮೆಂಟ್ ಮಾಡೀನಿ ಅಂದ್ರೆ ಡಬಲ್ ಬಾಂಡು ಉಳಿದಿದ್ದು CH2 ಹಂಗೆ ಬರ್ತೇನೆ. ಈಗ ನೋಡ್ರಿ ಇಲ್ಲಿ ನೀವು ಡಬಲ್ ಬಾಂಡ್ ಮಾಡಿದ್ರಿ ಅಂತಂದ್ರೆ ಈಗ ಇಲ್ಲಿ ಏನಾಕೈತಿ, ಇದು ಈ ಡಬಲ್ ಬಾಂಡ್ ಇದ್ದಿದ್ದು ವ್ಯಾಲೆನ್ಸಿ ಏನಾಯ್ತು, ಇಲ್ಲಿ ಆಲ್ರೆಡಿ 1 2 3 4 ಅದ. ಈಗ ನೀವು ಮತ್ತೊಂದು ಕಳಿಸಿರಿ 5 ಆಯಿತು. ಅವಾಗ ಆಟೋಮೆಟಿಕ್ಲಿ ಇಲ್ಲಿರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ಲಿ ಮ್ಯಾಲೆ ಬಂದು ಅಲ್ವಾ. ಓಕೆ, ಅದನ್ನೇ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅವರು ಇಲ್ಲಿ ತೋರಿಸಿದ್ದಾರೆ. ಓಕೆ, ನೌ ಸ್ಟೂಡೆಂಟ್ಸ್, ದೀಸ್ ಆರ್ ರೆಸೋನೇಟಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್. ಇಸ್ ಇಟ್ ರೈಟ್? ದೆನ್ ಐ ಥಿಂಕ್ ಯು ನೋ ವಾಟ್ ಆರ್ ರೆಸೋನೇಟಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್. Resonating structures, these are the structures which individually do not show the original structure. These structures are also called as canonical structures, hypothetical structures, etc. Okay, the correct answer for this question is option C. Sorry, option A, resonating structures. Option A is the right answer. Next question number 54, students. Which of the following pairs of the compounds are enantiomers? Yes, very important. This type of questions are observed usually in presence of DAEE as well as NEET level examination. So carefully observe the given options. What is the question? Which of the following pair compounds are enantiomers? Students, when you observe the given options structures, first you know compounds which are mirror images of each other and non-superimposable are termed as enantiomers. Is it right? Yes. If you know that concept, when you observe the given structures, then your answer is which one is mirror image and non-superimposable here. First come to the point of first structures. These are not mirror images because here H is present, here OH is present. Okay, no, therefore this one is wrong. Is that right? Yes, this one is wrong. And here OH is okay, this one is mirror images, I think. Okay, yes, right, this is mirror image. If you place this structure, if you place this structure on this, then it is non-superimposed because here OH is placed on H. Is it right? Yes. Okay, according to the question, this one is right answer. Next, here this one is not mirror image and this one is also not mirror image. Okay, therefore the correct answer for this question is option B. These two are enantiomers. Next, question number 55, students. Number of chiral carbon in beta D plus glucose. Students, you already learned biomolecule chapter, then you know the structure of D plus glucose. You yourself you try first. I think the calculation of chiral carbon atoms in presence of glucose and fructose, I told you. Okay, just you apply that concept in beta D glucose, beta D plus glucose. Okay, I will write the structure also, beta D plus glucose structure. Okay, see here chiral carbon atom, here one OH, here H, and here H, OH, here OH, here C, and here H, and here another carbon atom with H, OH, and here only I write H, and this one is involved in the chain, and here CH2OH. Okay, students, total number of carbon atoms here 1, 2, 3, 4, 5, 6. Is it right? Why beta present here? Because hydroxyl group present on left side. Is it right? This direction. Okay, ಇಲ್ಲಿ ಈ ಕಡೆ ಇತ್ತಂದ್ರೆ ಆಲ್ಫಾ ಬರೀತಿದ್ರಿ, ಈಗ ಈ ಕಡೆ ಅದ OH ಬರದೆ. Okay, beta. The point is number of chiral carbon atoms. What is chiral carbon atom? This is also called as asymmetric carbon atom. I told you. Is it right? Yes. Students, this chiral carbon atom, one of the carbon atom is surrounded by 4 different groups. Is it right? Yes. When you observe the 6th carbon atom here, 6th carbon atom here, CH2H means I write this one is also like this, CH2. Okay, instead of this H2. Is it right? At the time here also H, here also H. This is not a asymmetric carbon atom. But come to the point of this. Here carbon atom, here H is present, here one entire group is present, here entire group. Okay, this one is chiral carbon atom. Similarly this one, this one, this one, and this one. Okay, it contains from C1 to C5, means 5 chiral carbon atoms. Therefore alpha D plus glucose contains 5 chiral carbon atoms. ನಿಮ್ಗೆ ಗೊತ್ತಿರ್ತದ ಒಂದು ಕಾರ್ಬನ್ ಆಟಮ್, ಈಗ ಸಪೋಸ್ ನೋಡ್ರಿ ಥರ್ಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡೇನಿ ಅನ್ಕೊಡ್ರಿ. ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಈ ಕಡೆ ಎಚ್ ಅದ, ಈ ಕಡೆ OH ಅದ, ಈ ಕಡೆ ಇಲ್ಲೊಂದು ದೊಡ್ಡ ಗ್ರೂಪ್ ಅದ, ಈ ಕಡೆ ಒಂದು ದೊಡ್ಡ ಗ್ರೂಪ್ ಅದ. ಹೌದಾ? ಹಾಗಾದ್ರೆ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಸುತ್ತ ಡಿಫ್ರೆಂಟ್ ಗ್ರೂಪ್ ಕಂಡು ಬರತ್ತಾವ. ಅಂತದಕ್ಕೆ ಏನಂತಾನೆ ಅಸಿಮೆಟ್ರಿಕ್ ಆರ್ ಕೈರಲ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಕರಿತೇನೆ. ದೇರ್ ಆರ್ 5 chiral carbon atoms in alpha D plus glucose. Therefore option A is the right answer. Next, question number 60. Question number 60, students. The aromatic compound formula C7H7Cl has in all isomers. Okay, ಇದರದ isomers ಅನ್ನ ಬರಿಬೇಕು ನಾವು ಇಲ್ಲಿ. ಯಾವುದಿದು C7H7Cl ಅಂದ್ರೆ? Okay, mono derivative. Sorry, I write the isomers of the compound C7H7Cl like this one. I write here the structures. Here on benzene ring, one side there is a CS3 group and one Cl. This is one structure, and another structure here CS3 group, and in the here Cl group meta position, and in para position one structure here in the above CS3 group, and para position there is Cl group. And another type of structure containing same molecular formula is CH2Cl. Is it right? Yes. Okay, students, there are four structures. First one is alpha chlorotoluene or orthochlorotoluene, and second one is metachlorotoluene, and another third one is parachlorotoluene, and fourth one is benzyl chloride. This one is benzyl chloride structure. Yes, this one is benzyl chloride. Okay, students, it contains four structure isomers. Is it right? Is it right? An aromatic compound of formula C7H7Cl has four isomers. Therefore, the correct answer for this question is option C. Option C is the right answer because it contains three isomers. Students, one more important thing means one trick. It helps to the calculation of structural isomers. Okay, what is that? See here, I write in separately here. Remember those formulas. Either ನಮ್ಮ structural isomers ಯಾವಾಗಿದು in presence of aromatic compounds, aromatic rings ಇರಬೇಕಾದ್ರೆ ಹೆಲ್ಪ್ ಆಗ್ತದೆ. ಯಾವುದು? ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲಿ ಬರೀತೀನಿ ನಾನು. ಸಪೋಸ್ ಫಾರ್ಮುಲಾ ಹೇಗಿರಬೇಕು? C6H3XYZ. ಹಿಯರ್ 3 ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಗ್ರೂಪ್ಸ್, 3 ಬೇರೆ ಬೇರೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ಇದ್ದಾಗ ನಾವು ಏನು ತಗೋಬೇಕು? n = 3 ಅಂತ ತಗೋತೇವೆ. n = 3, and formula is 2 to the power of n plus 2 equal to 10 isomers ಕಂಡು ಬರ್ತಾವೆ. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಈ ಅರೋಮೆಟಿಕ್ ಕಂಪೌಂಡ್ ಫಾರ್ಮ್ಯಾಟ್ ಏನದ? C6H3XYZ ಮೀನ್ಸ್ 3 ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಗ್ರೂಪ್ ಪ್ರೆಸೆಂಟ್ ಅದಾವೆ. ಇಲ್ಲಿ 3 ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ಬೇರೆ ಬೇರೆ ಇರ್ತಕ್ಕಂಥವಿದ್ದಾಗ ಫಾರ್ಮುಲಾ 2 to the power of n plus 2 ಅದನ್ನು ಫಾಲೋ ಮಾಡಬೇಕು. ವೇರ್ n = ಏನಾಗಿದೆ? ಇಲ್ಲಿ 3 ಆಗ್ಯದ. ಅಂದರೆ ಟ್ರೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಗ್ರೂಪ್ ಇದ್ದಾಗ. If n = 2 ಇದ್ದಾಗ then use the formula 2 to the power of n plus 2. Yes, during this time his value is equal to 6. Is it right? Yes. Next, if n = 1 means it is observed like in the formula C6H3XX. Okay. XXX means mono substitute. ಇಲ್ಲಿ ಎಲ್ಲ ಒಂದೇ ಐತಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಎರಡು ಇದ್ದಾಗ ಏನಿರ್ಬೋದು? ಇದು C6H3XXY ಅಂದರೆ ಎರಡು ಸೇಮ್ ಅದಾವ, ಅಂದ್ರೆ ಒಂದು ಇದ್ದಂಗೆ ಆಯ್ತು. ಇದೊಂದು, ಹೌದಾ? ಅಂದರೆ ಎರಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ ಆದಾಗ ಅಲ್ಲಿ ಐಸೋಮರ್ಸ್ 6 ಇರ್ತಾವ. ಮೊನೋ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಇದ್ದಾಗ ಐಸೋಮರ್ಸ್ 3 ಇರ್ತಾವ. Because during this time use the formula 2 to the power of n plus 1 equal to 3. 3 isomers are present in mono substituted group. Okay, students, next question number 62. How many acyclic structural isomers are possible for the compound with molecular formula C3H3Cl3? Carefully observe here, students. The question is, how many acyclic structural isomers are possible for the compound with molecular formula C3H3Cl3? Students, the given options are: option A is 3, option B is 2, option C is 5, option D is 6. When you observe the given question, the molecular formula C3H3Cl3, it is related to the parent carbon C3H6. ನೋಡಿ ಏನಾಗಿದೆ ಯೂಸ್ವಲಿ ಇದರಲ್ಲಿ ಇಲ್ಲಿ C3H3Cl3 ಸಪೋಸ್ ಈ C3H6 ಇತ್ತಂದ್ರೆ ಏನಾಗಿತ್ತು ಅಲ್ಕಿನು ಹೌದಾ C3H6 ಪೇರೆಂಟ್ ಚೇನ್ ಆಗಿತ್ತು ಬಟ್ ಈಗ H6ದೊಳಗೆ 3 ಹೈಡ್ರೋಜನ್ ಏನಾಗ್ಯಾವ Cl ಇಂದ ರಿಪ್ಲೇಸ್ ಆಗ್ಯದ ಹೌದ್ರಿ ಅದಕ್ಕಾಗಿ ಇದು ಪೇರೆಂಟ್ ಚೇನ್ ಏನಂತ ಹೇಳ್ಬೋದು ನೀವು ಪೇರೆಂಟ್ ಚೇನ್ C3H6 ಅಂತ ಹೇಳ್ಬೋದು ಓಕೆ C3H6 ಅಂದ್ರೆ ಯಾವ್ದ್ರಿ ಅದು ದಟ್ ಈಸ್ propene is it right yes you know structure of propene is CS3CH double bond CH2 yes okay now acyclic structural isomers is it right yes how many I write structure one by one students when you observe the question here 3 chlorine atoms can replace hydrogen in such way that see here in that first structure I write ಏನು ಮಾಡ್ತೇನೆ ನೋಡ್ರಿ ಇಲ್ಲಿ ಈ ಏನು CH3 ಐತಲ್ಲ ಈ H3 ಅಂದರೆ ಈ 3 ಹೈಡ್ರೋಜನನ್ನು ರಿಪ್ಲೇಸ್ ಮಾಡಿ ಇದಕ್ಕೆ 3 Cl ಹಾಕ್ತೇನೆ ನಾನು ಹೇಗೆ ಇಲ್ಲಿ ನೋಡಿ ಅಲ್ಲಿ ಉಳಿದಿದ್ದೇನು ಒಂದು C ಉಳ್ಕೊಂಡದ ಅದ್ರ ಜೊತೆಗೆ Cl3 ಅಂತ ಬರ್ಕೋತೇನೆ ಅಂದರೆ H3 ಬದಲಾಗಿ 3 Cl ಆಯಿತು ಉಳಿದಿದ್ದೇನು CH ಡಬಲ್ ಬಾಂಡ್ CH2 ಇದು ಒಂದು ಐಸೋಮರ್ ಆಯಿತು ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ ಆ ಥರ ಬರಿಬೋದು ನೀವು ಅನ್ಬೋದು ಸರ್ ಇಲ್ಲಿ ಈ H3 ಒಳಗೆ 2 H ರಿಪ್ಲೇಸ್ ಮಾಡಿರಿ ಅಂದರೆ ಈ ಥರ ಬರಿತೇನೆ ನಾನು ಸಿ ಆಫ್ ಇಲ್ಲೊಂದು Cl ಬರಿತೇನೆ ಇಲ್ಲೊಂದು Cl ಬರಿತೇನೆ ಅಂದರೆ 2 Cl ಅನ್ನು ಕೊಟ್ಟಂಗೆ ಆಯಿತು ಹಂಗಾರೆ ಇಲ್ಲಿ ಉಳಿದಿದ್ದೇನು ಒಂದು H ಬರಿತೇನೆ ಇಲ್ಲಿ ಈ ಸಿಂಗಲ್ ಬಾಂಡ್ ಇರಲಿ ನೆಕ್ಸ್ಟು ಈ ಸಿ ಇಲ್ಲಿ ಬರಿತೇನೆ ಈ H ಐತಲ್ರಿ ಇದನ್ನೊಂದು ರಿಪ್ಲೇಸ್ ಮಾಡ್ತಾನೆ ಈ H ಬದಲಾಗಿ ಏನು ಬರಿತೇನೆ ನಾನು ಇಲ್ಲಿ ಒಂದು Cl ಬರಿತೇನೆ ಯಾಕಂದ್ರೆ ಟೋಟಲ್ 3 chlorine atoms are replaced the hydrogen atoms is it right yes next here double bond CH2 yes this is also another isomer observe the molecular formula of 1 and 2 it is similar to C3H3Cl3 yes next another structure third one how you write okay practice this students I write as Cl2CH double bond CH2Cl yes ಇಲ್ಲಿ ಏನು ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ದೇನೆ ನಾನು ಇಲ್ಲಿ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ Cl ಆ್ಯಡ್ ಮಾಡಿದ್ದೇನೆ ಇಲ್ಲಿ ಒಂದು H ಬದಲಾಗಿ ಏನು ಮಾಡೀನಿ ಇಲ್ಲಿ ಒಂದು Cl ಅನ್ನು ಇಲ್ಲಿ Cl2 ಆ್ಯಡ್ ಮಾಡಿದ್ದೇನೆ ಎಸ್ ನೆಕ್ಸ್ಟ್ ಫೋರ್ತ್ ಒನ್ Cl CH2 C of here one Cl double bond CH Cl is it right this is also one structure next fifth one I write Cl CH2 CH double bond C Cl2 C of Cl2 S C of sorry here CH double bond sorry here C of Cl2 double bond is already present here and 2 chlorine atoms okay next another one structure sixth one that is CH3 C of Cl double bond C here one Cl and here one Cl okay so there are 6 structures are possible which type of structures acyclic structural isomers therefore the correct answer for this question is option D 6 isomers are possible okay students next question number 63 geometrical isomerism can be shown by students this is one of the very easiest example and easiest problem because we know in presence of alkenes the geometrical isomerism is shown and the carbon containing double bond shows or alkenes containing means means it contains double bond no double bond containing compound shows geometrical isomerism is it right yes therefore I write direct answer for this question that is option C C triple bond C okay students next come to the another question 64th very important the number of optical enantiomers of tartaric acid are very interesting this example is sorry this problem is observed many times in examination. So carefully observe here. The number of optical enantiomorphs of tartaric acid are option A 1, option B 4, option C 3, option D 2. Students, the name given compound name is tartaric acid. As now must and should you know the structure of tartaric acid. And remember students, tartaric acid is an example of a symmetrical molecule having two asymmetric carbon atoms. Remember, this is very important. Tartaric acid is one example of symmetrical molecule. It contains two asymmetric carbon atoms. You already know what is asymmetric carbon atom. That carbon atom is surrounded by four different groups. In such cases, no optical enantiomers. In such cases, number of optical enantiomers are observed. Number means that can be calculated by using one formula. Before going to the formula, first you write the structure of tartaric acid here. I write here. Yes, students, COOH here. OH H and here CHOH and here COOH. Students, this is the structure of tartaric acid. Is it right? Yes. What about this carbon atom? It is a symmetric or symmetric carbon atom. Observe carefully. As this is asymmetric carbon atom because it contains here one H, here OH, here entire different group and here COH group. Is it right? Therefore, it is one of the asymmetric carbon atom. What about this? This is also asymmetric carbon atom. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಈ ಸೈಡ್ OH ಐತಿ, ಈ ಕಡೆ H ಅದ, ಇಲ್ಲಿ COOH ಅದ, ಈ ಕಡೆ ಒಂದು ದೊಡ್ಡ ಗ್ರೂಪ್ ಅದ ರೀ. ಅದಕ್ಕಾಗಿ ನಾವೇನು ಹೇಳಿದೆ, ಈ ಟಾರ್ಟಾರಿಕ್ ಆಸಿಡ್ ಒಳಗೆ ಎರಡು ಅಸಿಮೆಟ್ರಿಕ್ ಕಾರ್ಬನ್ ಅಟಮ್ ಕಂಡು ಬರಾಕತ್ತಾವ ಅಂತ ಹೇಳ್ತೀರಿ. ಎಸ್, ನೌ another thing I write here, number of optical enantiomers. Number of optical enantiomers. Number of optical enantiomers. The enantiomers is observed in presence of D and L, dextro and levorotatory isomers. Isomers can be calculated by formula 2 to the, I write here, 2 to the power of n minus 1 equal to, here n means number of asymmetric carbon atoms. So 2 minus 1 means it is 1. Therefore, it contains two isomers. Yes, therefore, the correct answer for this question is option D. Next, question number 65. Keto-enol tautomerism is observed in. Students, when you come to the point of keto-enol tautomerism, it is very important to know which type of compound shows keto-enol tautomerism. Students, keto-enol tautomerism is shown by the carbonyl compounds having alpha hydrogen atom. This is very important. Remember, which type of compound shows? Which type of compound shows keto-enol tautomerism? Which contain alpha hydrogen atom. Yes, now what is alpha hydrogen atom? The hydrogen atom which is present on alpha carbon atom is called as alpha hydrogen atom. Then what is alpha carbon atom? Okay, students, when you observe the given options for this particular question, the given A and B compounds contain alpha hydrogen atom. Yes, see here. ಇಲ್ಲಿ ಸರ್ ನಮಗೆ ಅಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂದ್ರೇನು, ಅಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಅಂದ್ರೇನು ಗೊತ್ತಾಗಬೇಕಾಗ್ಯದ ಮೊದಲು. ಹೌದಾ? ಹಾಗಾದರೆ ಇಲ್ಲಿ ಸ್ವಲ್ಪ ನೋಡಿ. ಈಗ ಸಪೋಸ್ ಈ ಎಕ್ಸಾಂಪಲ್ ಬಿ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಕತ್ತೀರಿ ಅನ್ಕೊಳ್ರಿ. ಈಗ ಇಲ್ಲೊಂದು ಕೀಟೋನ್ ಗ್ರೂಪ್ ಅದ. ಹೌದಾ? CO ಅನ್ನೋದದ ಒಂದು. ಈ ಗ್ರೂಪ್ ಪಕ್ಕದಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಹೈಡ್ರೋಜನ್ಸ್, ಅದಕ್ಕಿಂತ ಮೊದಲು ಬೇಕಾದ್ರೆ ಕಾರ್ಬನ್ ಆಟಮ್ ತೊಗೊಂಡ್ರೆ, ಈಗ ಸಪೋಸ್ ಈ ಕಾರ್ಬನ್ ಆಟಮನ್ನು ನಾನು ತೊಗೊಂಡೆ ಇಲ್ಲಿ. ಹೌದಾ? ಇದೇನಿರ್ತದೆ, ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಪಕ್ಕದಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಆಗಿರ್ತದೆ. ಹೌದಾ? ದಿಸ್ ಈಸ್ ಅಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್. ಈ ಅಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಜೊತೆ ಇರ್ತಕ್ಕಂಥ ಹೈಡ್ರೋಜನ್ಸ್ ಇಲ್ಲದಾವ ನೋಡ್ರಿ, 3H, ಇವೇನಿವು ಅಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್. ಓಕೆ, Similarly here functional group is present. Here CH2 means this one is the functional group carbon atom and this one is alpha carbon atom. These hydrogens are alpha hydrogen atoms. Okay, means if you know this concept, then your answer both A and B shows the keto-enol tautomerism. Therefore, the correct answer for this question is option D. Why option C is not correct? Because here it do not contain alpha hydrogen atoms. The CHO means it is one of the earlier groups. Is it right? Yes. Option D is the right answer. Okay, students, next question number 70. Question number 70. The correct statement about the compound A, B and C is, okay, carefully observe the structures, how they are arranged, which type of groups are present in there. Okay, yes, option A is A and B are identical. Option B is A and B are diastereomers. Option C, A and C are enantiomers. Option D, A and B are enantiomers. Okay, students, I think in the previous question I already told you what are diastereomers, what are enantiomers and what are identicals. Okay, if you know that concept, it is very easy to answer this question. Okay, see once again. Diastereomers. What are diastereomers, students? Diastereomers have the same configuration at one chiral carbon atom. Remember, diastereomers have same configuration at one chiral carbon atom and different configuration at other carbon atom. Is it right? Yes. Next, what are enantiomers? Enantiomers are the non-superimposable mirror images of each other. Mirror images, but they are non-superimposed. Okay. Students, usually when you compare the A and B structure, is it right? What observed here? Here the structure B is rotated at 180 degree. Is it right? Yes. Okay, students, if you know all the points related to diastereomers and enantiomers, after that you observe this problem. Here A and B are identical. Is it right? Yes. Here A and B are identical. Next, rotate the structure B 180 degree and observe. Rotate the structure B 180 degree and observe A and C are enantiomers. Usually here A and C are enantiomers. A and C are enantiomers. B and C are diastereomers. Sorry, here these are A and C are not enantiomers. A and C are diastereomers. Here A and C are diastereomers. B and C are also diastereomers. And A and B are identical. A and B are identical. Okay, which one is given in the option? A and B are diastereomers? No, A and C are diastereomers. A and B are identical. Okay, therefore option A is the right answer. Next, question number 71. The molecular formula of diphenylmethane is. The molecular formula of diphenylmethane is. Students, the molecular formula of diphenylmethane is C13H12. Okay, how many structural isomers are possible when one of the hydrogen is replaced by chlorine atom? ಈ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್ ಒಳಗೆ ಅದ್ರ ಮಾಲಿಕ್ಯುಲರ್ ಫಾರ್ಮುಲಾ ಏನದಂತ C13H12 ಅದ. ಅದ್ರ ಒಳಗೆ ಅಕಸ್ಮಾತ್ ಎಲ್ಲೋ ಒಂದು ಹೈಡ್ರೋಜನ್ ರಿಪ್ಲೇಸ್ ಆಗಿ, ಹೌದಾ, ರಿಪ್ಲೇಸ್ ಆಗಿ ಕ್ಲೋರಿನ್ ಆಟಮ್ ಅಟ್ಯಾಕ್ ಆದರೆ ಅಲ್ಲಿ ಎಷ್ಟು ಸ್ಟ್ರಕ್ಚರಲ್ ಐಸೋಮರ್ಸ್ ಕಂಡು ಬರ್ತಾವ ಅಂತಕ್ಕಂಥದ್ದು. ಓಕೆ, ನಾನೀಗ ಒಂದೊಂದಾಗಿ ಸ್ಟ್ರಕ್ಚರ್ ಬರಿತಾ ಬರ್ತೇನೆ, ಇಲ್ಲಿ ನೋಡ್ತಾ ಹೋಗಿ. ಸಪೋಸ್ ಈಗ ನೋಡ್ರಿ, ಅದೇ ಸ್ಟ್ರಕ್ಚರ್ನ ಮೊದಲು ಬರ್ಕೊಳ್ತಾನೆ ಇಲ್ಲಿ, ಹೌದಾ. ಏನದ CH2, ಇಲ್ಲೊಂದು ಮತ್ತು ಬೆಂಜಿನ್ ರಿಂಗ್ ಅದ, ಹೌದಾ. Okay, suppose here it contains hydrogen atom. If it replaced by one Cl. Okay, this one is the isomer. Next, another one. Here CH2 and here one benzene ring. Is it right? Yes. Now I replace this hydrogen atom by chlorine. Sorry. Here replace this hydrogen by chlorine atom. Yes. These are two structures and another structure. Here CH2 S. I replace the position. Yes, here I write Cl and okay. Here CH. Instead of CH2 I write only CH and that hydrogen is replaced here by Cl. Okay, and this one is the another isomer. These are 4 structures are observed. Remember students, 4 structural isomers are possible for diphenyl methane. Okay, where is the answer? B means 4. Okay, B is the right answer. B is the right answer. ನೀವು ಇಲ್ಲಿ ಅನ್ಬೋದು ಸರ್ ಈ ರಿಂಗ್ನಾಗ ನೀವು ಸಿ ಎಲ್ ಎಲ್ಲ ರಿಪ್ಲೇಸ್ ಮಾಡಿದ್ರಿ, ಅದೇ ಥರ ಈ ರಿಂಗ್ದೊಳಗೂ ಸಿ ಎಲ್ ರಿಪ್ಲೇಸ್ ಮಾಡ್ಬೋದಾಗಿತ್ತಲ್ಲ ಅಂತೇಳಿ. ಸೊ ಅಲ್ಲಿ ಏನಾಗ್ತಾವೆ, ಐಡೆಂಟಿಕಲ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಗಿ ಕಂಡು ಬರ್ತವೆ, ಎರಡು ಸೇಮ್ ಅಲ್ವಾ. ಇದನ್ನೇ ನೀವು ಸ್ಟ್ರಕ್ಚರನ್ನು ಈ ಥರ ರಿವರ್ಸ್ ಇಟ್ಟಂಗೆ ಆಗ್ತದೆ, ಅಲ್ಲಿ ನಾವು ಅವನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳಕ್ಕಾಗಂಗಿಲ್ಲ. ಓಕೆ, ಎಸ್. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 77. ಸೆಲೆಕ್ಟ್ ದ ರೆಸ್ಪಾನ್ಸ್ that correctly identifies the number of carbon atoms of each type of hybridization in the compound given below. Okay, CH2, observe the given compound carefully. The carbon atom involved different type of hybridization. Select the response that correctly identifies the number of carbon atoms of each type of hybridization in the compound given below. Okay, first I write the given structure another once again. Here CH2 double bond C, here double bond CH, here single bond CH, double bond O. Students, you know one concept. If sp3 hybridization involved carbon atom is present, then it contains 4 sigma bonds. Is it right? Yes. If sp2 is present, it contains 3 sigma 1 pi. And if sp is present, 2 sigma and 2 pi. If you know this concept, then this question is very easy. Okay, observe here double bond means 1 sigma 1 pi. Is it right? 1 sigma bond sorry double bond ಐತಿ ಅಂದ್ರೆ ಅಲ್ಲಿ ಒಂದು ಸಿಗ್ಮಾ ಇರ್ತದ, ಒಂದು ಪೈ ಇರ್ತದ ಅಂತ ಗೊತ್ತದ. ಇಲ್ಲಿ 2 H2 ಅದ ಅಂದ್ರೆ ಈ ಕಡೆ ಒಂದು H, ಈ ಕಡೆ ಒಂದು H. So here 2 sigma. Yes, this carbon atom contain 3 sigma 1 pi. Is it right? 3 sigma 1 pi. 3 sigma 1 pi ಇದ್ರೆ ಯಾವುದದು? sp2 ಅಲ್ವಾ? Yes, sp2. Similarly, this carbon atom, here 1 sigma 1 pi and here 1 sigma 1 pi. Okay, 2 sigma 2 pi means this carbon atom possesses sp hybridization. What about this? Here 1 sigma 2 3 sigma 1 pi, therefore it shows sp2 hybridization. And here what about this carbon atom? Here 1 sigma, here 1 sigma, here 1 sigma and 1 pi, therefore it also shows sp2 hybridization. Okay students, number of means sp3 hybridization, number of sp3 hybridized carbon atoms here, sp3 is 0. Is it right? Okay, I write here sp3 carbon atoms 0. ಈಗ ಈ ಸ್ಟ್ರಕ್ಚರ್ ಒಳಗೆ ನಮಗೆ sp3 ಕಾರ್ಬನ್ ಐಟಮ್ಸ್ ಕಂಡು ಬರ್ತಾ ಇಲ್ಲ, ಅದಕ್ಕೆ 0 ಅಂತ ಬರದೆ. sp2 ಎಷ್ಟು ಕಂಡು ಬರಾಕತ್ತಾವ್ರಿ? 1 2 3. Is it right? Yes, 3. ನೆಕ್ಸ್ಟ್ sp ಎಷ್ಟು ಅದಾವ? ಇಲ್ಲಿ ಒಂದದ. ಓಕೆ, sp1. ಓಕೆ, which one is the answer? sp3 sp2 sp3 0 3 1. Is it right? sp3 ಅನ್ನೋ 0 ಅದಾವ, sp2 ಅನ್ನೋ 3 ಅದಾವ, sp ಅನ್ನೋದು 1 ಅದ. Therefore the correct answer for this question is option C. Okay, next question number 78 students. Structures are given here: cyclopropane, cyclobutane and cyclobutadiene. pentane. Numbers also given 1, 2, 3. The correct order of heat of combustion of above compounds. Okay, which one has higher heat of combustion? Arrange in the increasing order. Okay, students, you know one concept. The compound which contain more number of carbon atoms, more will be the heat of combustion. This is one of the easiest point. If you know this point, then it is very easy to answer this question. What is the point? More the number of carbon atoms, more will be the heat of combustion. Okay, in among these three structures, which one compound contain more number of carbon atoms? Here cyclopentane means it contains 5 carbon atoms, therefore its heat of combustion is more. Therefore the one is greater than second one, because it contains 4 carbon atoms and another one contains 3 carbon atoms. That is your first structure. Okay, yes, therefore heat of combustion is observed in the order of third one is greater than second one is greater than first one. Which one is the answer? Yes, option C is the right answer. Option C is the right answer. Okay, students, next question number 79. One among the following compounds will not give appearance with the sodium carbonate. One among the following compounds will not give appearance with sodium carbonate. Which one it is? Students, observe carefully. Here phenol is given, picric acid is given. Okay, students, when you observe the given options, one thing you remember, phenol does not react with sodium bicarbonate. Remember, phenol does not react with sodium bicarbonate as well as not react with sodium carbonate. Picric acid is a phenolic compound. Yes, is it right? As picric acid, you know, 2,4,6 trinitrophenol. Yes, option D. 2,4,6 trinitrophenol, common name is picric acid, due to the presence of 3NaO2 group. 3NaO2. Sorry, the presence of 3NO2 group. NO2, it is an electron withdrawing group. It is highly acidic and react with sodium bicarbonate and sodium carbonate. And you know, one of the point, phenol is less acidic than others. Is it right? Yes, therefore option C itself is the right answer for this question. Because of 3NO2 groups, means electron withdrawing group, picric acid becomes highly acidic. Next, question number 81, students. Here one compound is given and in presence of ACNA3 it gives the product A. Which statement is incorrect in respect of the above reaction? Okay, students, first I complete this reaction with products. Here the product is okay, students, here I write positive charge and NO3 because this Br is lost here, and NO3 I write NO3 minus, and byproduct is AgBr. Okay, product of which statement is incorrect in respect of the above reaction? I write only the products and observe the options. Option A is product is aromatic, product has high dipole moment, product has less resonance energy, product is soluble in polar solvent. Okay, students, you know how you check the aromaticity by using Huckel's rule, is it right? Yes, by using Huckel's rules means the formula is 4n plus 2 pi electrons. Is it right? 4n plus 2 pi electrons. If the compound possesses this formula, then it is aromatic. Okay, n means here number of rings, therefore 4 into 1, the given structure 4 into 1 plus 2 equal to 6. Is it right? Yes, this contain 2, 2, 2, 6, 5 electrons, then it is aromatic. Okay, statement 1 is right. Next, when you observe the products, is it right? Remember, students, the ions are formed here, one carbocation and NO3 minus, usually it is an ionic. compounds. Okay, yes, students, remember ionic compounds or solvents usually dissolved in polar solvents and have high dipole moment. Therefore it is also second one is right point. Next, product is soluble in polar solvents. You know, students, ionic compounds are usually soluble in polar solvents. Therefore option D is also right statement. But product has less resonance energy. No, students, product has high resonance energy here. That is the main point. But here they given incorrect statement. Therefore your correct answer is option C. Option C is the correct answer, because they asked incorrect statement here. Next question number 56. Which of the following is not resonating structure of each other? Okay, students, you know what are resonance structures. Resonance structures means both contain the isomers or compound structures contain same molecular formula. Is it right? Yes. But when you observe the given options, resonating structures, these resonance structures are also called as, you know, canonical structures or hypothetical structures. But when you writing the resonating structures, you cannot change the position of an atom. Is it right? Yes. But observe the given options. Here the position of the atoms is changed. Is it right? Why? You observe here, if you come to the point of option A, here CS3 is present. Okay, CS3 is present here, but here N triple bond C is present, but here C double bond S is present, but here the arrangement of atoms is different. But when you observe other examples, there will be a similar atoms with similar arrangement. Is it right? Therefore it is means these option A isomers are not resonating structures. ಇಲ್ಲಿ ಯೂಶುವಲಿ ನಾವು ರೆಸೊನೆನ್ಸ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಬರೀಬೇಕಾದ್ರೆ ಆಟಮ್ ಪೊಸಿಷನನ್ನು ಚೇಂಜ್ ಮಾಡಬಾರ್ದು, ಹೌದಾ, ಅಲ್ಲೇ ಬರೀಬೇಕು. ಆದರೆ ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ದಾರೆ, ಅವರು ಅವನ್ನ ಬದಲಿ ಪ್ಲೇಸ್ಮೆಂಟ್ ಬದಲಿ ಮಾಡಿದ್ದಾರೆ. ಸೊ ಅದು ರೆಸೊನೇಟಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಗಂಗಿಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 90 ಸ್ಟೂಡೆಂಟ್ಸ್. Which of the following represent a set of nucleophiles? As students, remember the concept. What are electrophiles and nucleophiles? You know, students, electrophiles are the electron deficient species containing positive charge and migrated towards the electron rich center. Is it right? Yes. But here they asked about nucleophiles. Nucleophiles are the electron rich species. Is it right? Electron rich species. Electron rich species and containing a negative charge and migrated towards the electron deficient species. Is it right? Yes. Another one thing you remember, students, nucleophiles are Lewis acids. Sorry, electrophiles are electron deficient species, nucleophiles are electron rich species. When you observe the given options, here BF3, H2O and NH2, they contain set of electrophiles. ಇಲ್ಲಿ ನೋಡ್ರಿ BF3, ಈಗ ನಿಮಗೆ ಸ್ಟ್ರಕ್ಚರ್ ಗೊತ್ತದ, BF3. ಓಕೆ, ಇಲ್ಲಿ ನೋಡ್ರಿ BF3. I write the structure here, BF here 3. Is it right? Yes. ಇಲ್ಲಿ ನೋಡ್ರಿ 2 electron 4 6 3 ಬಾಂಡ್. If it got octet rule, it requires 2 more electrons. Is it right? Yes. Therefore it is electron deficient or electron poor electrons are present here. Similarly in the H2O, AlCl3 ಅಂದ್ರೆ it contains 6 electrons, To get octet configuration, it requires another 2 electrons. Therefore, it is also electron poor center. Okay, electron poor are means it accepts the electron from others. Is it right? If you know Lewis acids and Lewis bases. Lewis acids and acid is a substance which accept a pair of electrons. S. Therefore, A and B are a set of electrophiles. Is it right? Therefore, these are not nucleophiles. Next, option C. Cn minus. Okay, here negative charge means electron rich species is present. OH minus, usually you write OH minus, and RCH2 minus is present. Therefore, this is an example for nucleophile. This set is nucleophile set. Okay, next question number 94. Allyl isocyanide has option A 9 sigma and 4 pi bonds, option D 8 sigma and 5 pi bonds, 9 sigma 3 pi and 2 non-bonded electrons, option D 8 sigma 3 pi and 4 non-bonded electrons. Okay, students, for answer this question you must know the structure of allyl isocyanide. Okay, the allyl isocyanide structure is observed like this. I write CH2 double bond CH, single bond CH2, single bond N, triple bond C. Is it right? CH2 double bond CH, single bond CH2, single bond N, triple bond NC. Isocyanide. Okay. Yes. CN bardre C triple bond N bardre cyanide group. N triple bond C bardre isocyanide group. Okay, students, here CH2 means it contains here 2 sigma, and here double bond means it contains 1 sigma and 1 pi. Here H means 1 sigma, single bond means here also 1 sigma, and CH2 means here sigma and sigma. Sorry, here CH2 means sigma and sigma. Here single bond means 1 sigma. Is it right? Okay, and in the above nitrogen there are pair of electrons. Next, triple bond means it contains 2 pi and 1 sigma. Is it right? Yes. Okay, count the number of sigma bonds. Totally 1 2 3 4 5 6 7 8 9. Okay, 9 sigma bonds, 9 sigma bonds, 2 and 1 3 5 bond, and 2 non-bonded electrons. 2 non-bonded electrons. Non-bonded electrons present on nitrogen atom. Okay, which one is the answer? 9 sigma bonds, 3 pi bonds, and 2 non-bonded electrons. Okay, option C is the right answer. Allyl isocyanide has 9 sigma, 3 pi, and 2 non-bonded electrons. Okay, students, next question number 98. Which of the following will show aromatic behavior? How you check this question? By using Voekel's rules only. Easily you can check whether the compound is aromatic or not. Okay, we know Voekel's rule formula. What is the formula? Voekel's rule formula: 4n plus 2 5 electron system. Okay, come to the point of first structure. It is aromatic or not? Okay, students, here n indicates the number of rings. Here 2 rings are present. Here 4 into 2 plus 2 equal to 4 into 2 means 8. 8 plus 2 10. Is there 10 electrons? 5 1 means 2 electrons. Is it right? 2 4 6. No, it not follows Voekel's rule. Therefore, it is one of the non-aromatic unconjugated because it contains 6 5 electrons only. Okay, 6 5 electrons. Okay, next is the first member of aromatic compounds. You know, benzene. It follows Voekel's rule because ring, it contains only one ring. 4n plus 2. 4 into 1 plus 2 means 6 electrons. Here 4 into 1, is it right? Plus 2 equal to 6. 4 into 1 plus 2 equal to 6. Here 2 2 2, total 6 electrons. Therefore it follows Voekel's rule. Therefore, according to question, this is our aromatic compound. Next, option C. It is one of the acyclic compound, you know, sorry, it is one of the acyclic compound. And another one, as this one is anti-aromatic compound, anti-aromatic because it contains conjugated 4 5 electrons. Okay students, therefore the correct answer for this question is option B only. Next question number 103 students. Use the following data to answer the question below. Okay, here cyclohexene is given and in presence of hydrogen and nickel it changes to cyclohexane. Is it next another one? At the time that rate of enthalpy change is minus 28.6 Kelvin calorie per mole, and anthracene in presence of excess of H2 nickel catalyst, delta H formed is minus 116.2 Kelvin calorie per mole. Okay students, anthracene, calculate the resonance energy of anthracene. Okay students, observe carefully here. Anthracene is 14 5 electron system containing compound. Anthracene is 14 5 electrons, means 7 double bonds are present in the structure. Is it right? Yes, observe here. Anthracene structure is already they given 2 4 6 8 10 12 14. Therefore it is 14 electron system. There are 7 5 bonds. Expected heat of hydrogenation, is it right? Yes, it is already given minus 28.6. okay, this is, theoretical value, you remember this one. Expected heat of hydrogenation, expected heat of hydrogenation is equal to minus 28.6 into 7, because it contains 7 pi bonds. Okay, is equal to minus 200.2 Kelvin calorie per mole. But observed heat of hydrogenation equal to, they given minus 116.2. yes students, resonance energy are right here. Resonance energy, I write simply RE equal to E observed, means energy observed, minus energy calculated. Okay, use this formula, then becomes equal to minus 116.2 minus of minus 200.2. if you simplify this, you get the answer 84 Kelvin calorie per mole. Okay, which one is the correct answer for this question is students? Option A is the right answer. Remember the formula of resonance energy, it is E observed minus E calculated. Okay, next question number 108 students. The increasing order of stability of the following free radicals is, increasing order of stability of the following free radicals is. Students, remember one theoretical concept. The order of stability of free radicals is always in the order of C6H5 thrice, here C radicals is greater than C6H5 twice CH, is greater than CS3 twice C, greater than CS3 twice CH. Okay, the stabilization of the first two is due to resonance and the last is due to the inductive effect. Remember this point. Therefore the correct answer for this question is option B. Next question number 112. The number of sigma and pi bonds in molecule of acetonitrile respectively, the number of sigma and pi bonds. Okay, First, I write the structure of acetonitrile here. Okay, students, if you know the the structure as here CHH means CS3 C triple bond N. Yes, this is the structure of acetonitrile. Students, you know triple bond means it contains one sigma and two pi bonds. Is it right? Yes. Here sigma bond means one sigma. Sorry, single bond means one sigma. Here one sigma. Here one sigma. Here one sigma. Therefore, the total number of sigma bonds here 1, 2, 3, 4, 5. 5 sigma. And what about pi bonds? 2 pi bonds. Is it right? Yes. It contains 2 pi bonds. This type of question is compulsory for your CET, GEE as well as NEET level examination. Ithra sigma bond ಮತ್ತು pi bond calculate ಮಾಡೋದು ಇದ್ದೇ ಇರ್ತದೆ ಯಾವುದಾದರೂ ಒಂದು. So at the time first you remember the structure of the compounds. Okay students, which one is the correct answer for 112 question? Option D, 5 sigma bonds and 2 pi bonds. Okay. Next question number 114. Electromeric effect is a, yes, remember students, different type of electronic effects: hyperconjugation effect, inductive effect, mesomeric effect, resonance effect, and another one electromeric effect. When you compared with others, it is one different type of electromeric effect. Therefore question may be asked on this topic only. Okay, ಏನು ಈ ಒಂದು ಟಾಪಿಕ್ ಮೇಲೆ ಹೆಚ್ಚಿಗೆ ಕ್ವಶನ್ ಕೇಳುವಂಥ ಚಾನ್ಸ್ ಅದ. ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ಇದ್ರ ಬಗ್ಗೆ ಜಾಸ್ತಿ ತಿಳ್ಕೊಳ್ಳಿ. ಎಲೆಕ್ಟ್ರೋಮೆರಿಕ್ ಎಫೆಕ್ಟ್. Students, remember electromeric effect is purely a temporary effect. Why? Because it takes place in presence of only an attacking reagent. If you remove that attacking reagent in a particular reaction, the reaction becomes backward reaction. Okay, electromeric effect is purely a temporary effect and it is brought into play only at the requirements of attacking reagent. It vanishes means it appears out as soon as the attacking reagent is removed from the reaction mixture. ಇದು ಯಾಕೆ ಟೆಂಪರರಿ ಇಫೆಕ್ಟ್ ಅಂತ ಕರೀತಾರೆ ಇದಕ್ಕೆ? ಬಿಕಾಸ್ ಇಟ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಓನ್ಲಿ ಅಟ್ಯಾಕಿಂಗ್ ರಿಯೇಜೆಂಟ್. ಅಟ್ಯಾಕಿಂಗ್ ರಿಯೇಜೆಂಟ್ ಎಲೆಕ್ಟ್ರೋಫೈಲ್, ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಇಂಥವು ಏನಾರ ಬೇಕಾ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕಂದ್ರೆ, ಸಪೋಸ್ ನೀವೇನಾರ ಆ ರಿಯಾಕ್ಷನ್ದಾಗ ಅವ್ನು ತೆಗೆದುಬಿಟ್ರಿ ಅಂತಂದರೆ ಆ ರಿಯಾಕ್ಷನ್ನ ಮೊದಲೇಕಿನ ಸ್ಥಾನ ಹೋಗಿಬಿಡ್ತದೆ. ವಾಪಸ್ ಮೊದಲೇನಿತ್ತಲ್ಲ ರಿಯಾಕ್ಟಂಟ್ ಅದೇ ಆಗಿಬಿಡ್ತದೆ. ಅಂಥ ರಿಯಾಕ್ಷನ್ಸ್ಗೆ ನಾವು ಎಲೆಕ್ಟ್ರೋಮೆರಿಕ್ ಎಫೆಕ್ಟಲ್ಲಿ ಕಾಣ್ತೇವೆ. ಅದು ಟೆಂಪರರಿ ಎಫೆಕ್ಟ್ ಅಂತ ಅನ್ನಿಸ್ಕೊಳ್ತದೆ. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ 118 ಸ್ಟೂಡೆಂಟ್ಸ್. Which of the following is not correctly matched? Group showing positive resonance effect, group showing negative resonance effect. Students, observe the given options carefully. Option A, NHCOR positive R effect means positive resonance effect. COH group negative resonance effect. Similarly, carbonyl group. Okay, students, remember one thing. OH shows plus R effect. Is it right? Yes, because it contains a pair of electrons. Therefore, it shows positive resonance effect. But they given the OH group in presence of minus R effect. And C11O means carbonyl group shows positive resonance effect usually. But sorry, C11O should shows minus R effect means negative resonance effect, but they given in presence of positive R effect. Therefore option B is not correctly matched. Option B is not correctly matched. Next question number 119 students. Hyperconjugation involves overlap of following orbitals. Okay, means remember students, this one is also very important. In presence of inductive effect, sigma electrons are involved. In presence of mesomeric effect, the pi electrons are in presence of conjugated system. Usually the mesomeric effect happens. Is it right? Those points are very important. Please remember. Hyperconjugation involves overlap of which type of orbitals? Here orbitals, they asked orbitals. Remember, alkyl groups with at least one hydrogen atom on the carbon atom attached to the unsaturated carbon atom are able to release electrons in the following. Okay, yes. Students, one point to note that the delocalization involves the sigma and pi bond orbitals or p orbitals in case of free radicals. It is also known as sigma pi conjugation. This type of electrons release due to the presence of a system, H C C double bond C. Is it right? It is known as hyperconjugation. Therefore, option B is the right answer. Okay, students, next last question. 120. Which of the following represents the correct order of stability of the given carbocations? Okay, students, observe carefully the given options. And remember one thing, negative I group destabilizes the carbon cations. Remember, negative I group stabilizes the carbocation, and since inductive effect decreases with increase in the length of carbon chain, therefore B is the correct answer for this question. Remember one thing, minus I group means negative inductive group destabilizes carbocation, and since the inductive effect decreases with the increase in the length of carbon chain, you know this point, therefore B is the correct answer. Okay, students, observe different type of questions on this topic. If you have any doubt, and ask me also. And another one thing, for FUC first year students, I upload different type of questions on this topic only. You also refer those questions. If you subscribe my channel, then you get all videos with the different topics. Thank you, students.